In order to deeply understand the nitrogenase process, we'll need to talk about proteins and enzymes. And before we talk about proteins, we're going to talk about amino acids. Amino acids working together build proteins. We're going to break down amino acids into basic building blocks of their own and start with bonding. So in order to do this, I'm going to get out my sketch pad. Okay, amino acids. Let me start with my most favorite organic chemistry element, carbon. Carbon has 4 possibilities to bond. So I'm going to put a bond on each one of these on this carbon. I'm going to space it out nice and symmetrically. Now, if all of these carbons were bound to hydrogens, don't worry, we'll get to amino acids in a minute, but if all 4 hydrogens were hooked up to carbon, then this would be, can you guess what this compound is? This is methane. If you have natural gas, most of what you're getting is methane. So, let's see what this has to do with amino acids. I don't see any amino acids or anything like that. Well, before I go there, what shape would this be? What would the geometry be? Well, the geometry would be a tetrahedron. Now let's say, what in the heck is that? Well, you think of the C as being pulled up out of the plane of this drawing here, and each one of these would be sliding back, and because the electrons oppose each other, then that repulsion is going to space these things out nice and neat and evenly, and between each one of these axes is going to be an angle of 109 degrees. I think it's actually 109.5, but that's close enough. And because the electronegativity of hydrogen and carbon are not that different, it all forms this nice, neat little tent type formation. Now, where do we go from here? Well, I said we wanted to get to amino acids. So, let me see how well I can erase. Now, amino. On this side, I'm going to put the amine. And the amine always has nitrogen in it. Nitrogen is atomic number 5, and that means there are 3 bonds possible. So I'm going to just set this up nice and easy. I'm going to put an H up here and bond it to the nitrogen, and an H down here and bond it to the nitrogen. So you could call this NH2, but this shows the structure so much better. So this is the amine over here. So let's see if I can write amine. Amine. There's the amine. And on this side is going to be, so this is kind of the acid side, and this side's going to kind of be the base side. So if you have an acid, what do you have basic stuff in there? Well, the amino acids act like a buffer, and they will tend to maintain the pH of whatever medium they're in. These mediums can change quite a bit, but that's an important property of the amino acids. Now, what do we put on this side? Well, let's see. What do we put on this side? Well, I'm going to put another carbon here. Okay, there's one of the carbon bonds all used up. And then I'm going to put oxygen up here. And for this oxygen, the oxygen has an atomic number of 6, so we only have 2 electrons that we need to share between the carbon and the oxygen. And we're going to make this a double bond. So we've used up all of the electrons needed to get to the magic number of 8 in all of these cases. All of these have the magic number of 8 satisfied. You say, wait a minute, but there's another bond of carbon left over. Oh, there is. Thanks for reminding me. There's another bond of carbon, and that happens to be, I'm going to bind that to O, and then I'm going to put an H out here. Now let's see if that works out. Oh, let me put the crossbar for the H. Now, does that look like anything? Well, OH is like the hydroxyl part in water. So this whole group here, the carbons, the oxygen, and the hydrogen, all those work together, and that can be called a carboxyl group. Gotta keep the pen down here. There's the carboxyl group. And let me clean that up just a little bit. There. See, there's the B, the carboxyl group over here. And here we've got the central atom and the hydrogen. So let's review here what we've got. All of these have, this still will be kind of a tetrahedral shape here. Oh, I know what. I'm going to erase one of these hydrogens. I'm going to erase that hydrogen. I'm just going to put a big R there. That R stands for a functional group. Now, each one of the 20 amino acids has a different replacement for this R, which is a functional group. Not a single atom, but there's different groups of atoms that fit on there. So, amine, carboxyl, functional group, that is the amino acids.